Okay, this is lesson 41, Algebra 1. So we're going to start adding rational expressions and learning about two-step problems. So let's look at this rational expression. We said a rational expression is anything that's a fraction. This happens to be a complicated rational expression because you've got variables and you got into the negative power. Well, we've got three terms because remember a term is separated by a plus or minus. Now, in order to add these, you have to have the same denominator. They have to be like terms. Well, we can't really tell because they're all kind of crazy looking. So the first thing we want to do is we want to change it where all the exponents are positive. So this becomes bxy squared over x cubed minus 3b squared over x to the negative 2 and then we have, x squared plus 4y squared over bx squared. Now we can see none of these denominators are the same, therefore there's nothing we can do at this point. We will learn how to do that later. At this point, there's nothing we can do. So let's look at another problem. Let's look at b y squared over x squared minus 3by squared over x squared plus 4y squared over bx squared. What do we notice? These first two terms have the same denominator. Therefore, how do we add fractions? When you have the same denominator, you simply combine the numerators. Now, the next step is to say, are they like terms? If it was 3 and 4, we would add 3 and 4, which would make 7. But these are have variables. So again, we go back to what is a like term? You have b, you have both y squared. This has a coefficient of 1, so the numerators are like terms, so therefore it's 1 minus 3 is negative 2by squared over x squared. Just like fractions, you don't add or multiply or do anything with the denominator when you're adding or subtracting fractions. If you have the same denominator, you simply combine the numerators and you keep the denominator. Plus 4y squared over bx squared. And that's as far as you can go because these two are not the same denominator. This has a b, this doesn't. So you're done. That's as far as you can go. So let's look at example 41.1. It says bx over x cubed y to the negative 2 minus 3by squared x to the negative 2 plus 4y squared over b to the negative 1 x squared. Well, you can't tell if any of these are like terms or have the same denominator. So what you want to do is you want to change everything into positive exponents. So again, we're going back to those rules. If you don't know them, learn them. If you need some help, let me know in class so we can go over that rule again. So this moves to the top and the exponent becomes positive. You have bxy squared over x cubed minus, can't forget that sign, 3b by squared over x squared plus 4by squared over x squared. Now we see that these two aren't the same, so you can't combine the numerators. But these two are the same denominator, so therefore you can combine the numerators if they are like terms. And we see we have a b and a b, a y squared and a y squared, so we can combine the coefficients. This coefficient is a negative 3. This is a positive 4. What's a negative 3 and a positive 4? Use our integer rules. It's simply 1. So our answer is bxy squared over x cubed. I know there's a little glare there. Sorry about that. Plus, because remember, this is bigger than that and it's positive, and it's 1, it's implied 1, so we don't have to write that. by squared over x squared is simply your answer. And that's how you would leave it. You can't change it. So let's look at example 41.2. A to the negative third b over b to the negative third plus 2b to the fourth over a cubed. Well, first I've got to change these to positive exponents. So we have, this goes up, so you have b cubed b over a cubed plus 2b to the fourth over a cubed. Well, this is the same thing as saying b to the fourth over a cubed plus 2b to the fourth over a cubed. So you have fractions. How do you have fractions? It's just simple fraction rules. You have to have the same denominators, do you? Yes, I didn't write very well. Okay, they're both a cubed. So now when you have the common denominator, you do what? You combine the numerators. But before we can combine the numerators, they must be like terms. b to the fourth power, b to the fourth power. Oh yes, coefficient of 1. So this becomes 3b to the fourth over a cubed. And that's your answer. And there's nothing else you can simplify. Okay, so the key is to change your negative exponents to positive. And then see, can you combine any? Meaning, do you have any of the same denominators? Common denominators, because that's how you combine fractions, is you have to have the same denominator. Once you do, then you simply combine the numerators. But, again, they have to be like terms. If this was b to the third, then this is your answer. You can't change it. Or you could put it all over a cubed, b to the third plus 2b to the fourth all over a cubed. You could do that as well. But you can't go any further. Alrighty? So let's look at example 41.b. We're going to start talking about two-step problems. It's just doing what you're doing, except for now we're adding a lot of letters. You can see where this is going. We're going to get really complicated here. So it said if x plus 3 equals 7, then what's the value of x minus 8? Well, first, all we're asking is we have to find x. So we're going to minus 3 using your steps for solving an equation, which will be on your test, so know them, equals 4. So now can we find the value of this? Yes, we can do 4 minus 8 equals negative 4. So the value of x minus 8 is negative 4. That's all it is. So let's look at example 41.5. It says, if x minus 5 equals 7, what's the value of x plus 4? Well, we're going to solve for x. We're going to add 5 to both sides. X equals 12. So what's the value of x plus 4? 12 plus 4 is 16. It's that simple. Don't make it complicated. If x minus 5 equals 7, then what's the value of x plus 4? Find x and then plug x back into it. That's all you're doing. Do your practice problems, and your code is have a great holiday. Happy Thanksgiving. Actually, just write Happy Thanksgiving on 40. No, excuse me. Lesson 39. Homework 39. Okay? Goodbye.